Hello students, today we are going to see sequencing problems in OR. Kindly subscribe my channel, then only you can get regular notifications for the videos which I am going to post one by one. Okay, come to the topic today. We are going to see about sequencing problems. What do you mean by a sequencing problem? Let me give the introduction for a sequencing problem. Suppose a publisher is going to publish books. Okay, he has two jobs. One is printing of the pages in the book and the other one is binding the pages together for getting a book. So he has two processes. One is the first job is printing and the second job is binding. So after doing these two, actually he is having an order. First one has to be the printing process, the second one is binding process. So first job is printing and the second one is binding. Okay, so he has to publish, for example, he has to publish 10 books a day. So within a day, he has to produce 10 books. In which order he has to produce, that we don't know. 10 books or different books, not the same book. Different 10 books he is going to publish on a day. He is going to complete the job and he has to publish on a day. So we have to find in which order these two has to be processed in order to minimize the time, because for a publisher, he is only the investor. No, he want to invest less. Okay, so the time schedule has to be minimized. For that, we have to find in which order we have to process these two jobs in order to minimize the total time. Okay, so for that only we are going to see in this unit. For that, in this unit, we are going to use one method that is called Johnson's algorithm or Johnson's method. That is the only method we are going to see here. Okay. Before that, let me explain these three definitions. The total elapsed time. Total elapsed time is nothing but when we start, the starting time and the final ending time, the difference between these two. For example, I will start from 0 time and if I end at the 10 hours means the total elapsed time is 10 hours. So this time when we are completing all the jobs, that is called total elapsed time. Ideal time means the time, total time at which the machines are ideal, that is there is no job for machines, that is called ideal time. And no processing rule means, in the previous example I said no, first one is printing and the second one is binding. Like that they will give in which order we have to process the jobs, that is called no passing rule. So in that order only we have to pass. Is it clear? The first type what we have is we are going to process n jobs on two machines. So only two machines we have to process n jobs. The same algorithm only we are going to use, Johnson's algorithm. The first problem what we have is there are 5 jobs, each of which is to be processed through two machines M1 and M2 in the order M1, M2. This is the no passing rule. In this order, the first one is M1 and we have to process all the jobs through M1, then it has to move on to M2. Processing hours are as follows. This is the time duration given. The first row is jobs. We have 5 jobs and 2 machines. In the first job, in machine 1 it will take 3 hours and machine 2 it will take 4 hours. Second job it will take 8 hours and 10 hours. Like that they have given the data. Using this data we have to find the sequence in order to minimize the total elapsed time. Determine the optimum sequence. Optimum sequence means minimum time, in which minimum time we are going to process. That is called the optimum sequence for the 5 jobs. And the minimum total elapsed time. So in order to minimize the total elapsed time, and we are going to find how many hours each machine is going to be ideal. The ideal time of machines of M1 and M2. This is the same data I have taken. First I am going to find in which sequence we are going to process the jobs. The process is very easy. So the data given, first you have to locate the least value. Which is the least value out of the given data? 3 is the least value. This least value, if it belongs to M1 means we have to take the job number in the left side. If it belongs to M2 means we have to take the job number in the right side. I repeat, first you have to locate the least value. If the least value belongs to the first machine, means we have to start from left side. If it belongs to the right side, means we have to start from the if it belongs to M1, means we have to start from the left side. If it belongs to M2, means we have to start from the right side. Here 3 belongs to M1 and the corresponding job is 1. So we have to take the at 1 in the left side. For example, here if you have 3, means it belongs to M2, so 1 has to be taken in this right side. But here it is not the case. That 1 is in the first machine, sorry, that minimum value belongs to the first job in M1, so we have to start from the left side. So this, if you have completed the job, means strike it out, because you are not supposed to take that further again. Okay, so this one already we have completed. Now come to the next least value. 4 is the least value. It belongs to M1, so we have to start from here only. It belongs to the job 5. So strike that job. Okay, now come to the next value 5. 5 we have in 2 places, this 5 and this 5. We have 2 5s, no, here and here. Simultaneously we take down that. So for this 5, the job is 3 and the machine is 1. So we have to take the job number 3 in the left side. And for this 5, the job number is 4 and it belongs to machine 2. So we have to start from right side 4. So simultaneously we have marked 2 jobs. So strike those 2 jobs. The balance what we have is only 2. So in between here it will come. So we got the sequence of jobs. I repeat, we have to locate the minimum. So 3 is the minimum. It belongs to M1. So first job 1 will come in the right side. Then 4 is the minimum. It belongs to job number 5, machine 1. So job number 5 will come here. 5 we have in 2 places, in M1 as well as in M2. In M1 the job number is 3 and M2 the job number is 4. So balance what we have is 2. So this is the optimum sequence in which we are going to process the jobs for getting the minimum processing time. Is it clear? Now we have to find 3 answers. They are total elapsed time, that is the completion. Total project has to be completed within a time, no, that time. Then ideal time for M1 and ideal time for M2. So how many hours both the machines are not working. So totally we are going to find 3 values. So for that I have taken a table. This is the order which we got now. Okay, so in this order only we are going to process the jobs 1, 5, 3, 2, 4. And for everything we have to take M1, M2. This is the time in and time out, time in and time out. So time in which time it is going to process, no, that is time in. Okay, we are going to start. Very first when I start, we will start from the 0 hour, because no, this is the first job we are going to start, no. So from 0 time we are starting. And for job 1 in machine 1, the time for processing is 3. So 3 hours we have to work in machine 1 for job 1. First we have to fill these 2 columns. Then we have to move on to the next machine. Okay. So 0 hour we are starting and it will take 3 hours. So here we have to take 0 plus 3, which is 3. And after completing this job, the next has to be processed in machine 1. So starting time for the next one is this time 3. So from the 3rd hour we have to start the next job 5, 3. And what is the processing time for job 5 in machine 1? 4. So 3 plus 4, it is 7. After 7 hours we have to start the next job here. So this 7 will come here. Okay. And for 3, the 3rd one, we have 5 hours, right? So 7 plus 5, it is 12. After this 12, we have to start the next job 12. 12 plus 4, 2 in machine 1. For 2 in machine 1, it is 8. So 12 plus 8, it is 20. From 20, we have to start. So 20 plus for 4, what we have is 7. 20 plus 7, it is 27. It is clear? So finally, we are getting after completing the sequence in machine 1, the last time duration what we have is 27. Now we are going to move on to the next machine. This job has to be processed M1 then M2 because this is the order what they have given. After completing all the jobs one by one in M1, then they have to move on to M2. Okay, so from 0 to 3 hours the machine is idle. From after completing here it has to move on to the next machine. So after completing means after the 3rd hour it has to move on to the next machine. Before that we are not able to process this at the 0 hour because from 0 to 3 it has to be processed in machine 1. So after the 3rd hour we have to start here. So from 3 it is the starting hour 3 and here 3 plus for job 1 in the machine 2 the time duration is 4 hours. So 3 plus 4 7 hours. Before you are not supposed to take this as it is, you compare these two values. Okay, so compare these two values. After comparison, which is maximum, that has to come here. Okay, these two are equal, so we have to take 7 as it is. Okay, so 7, then 7 plus 5. What is the time duration for 5 in machine 2? 8. 7 plus 8, which is equal to 15 hours. What I said, you are not supposed to take this value as it is. You compare these two, 12 and 15. Whichever value is maximum, we have to take that. Because this job only has to be processed in M2. Am I right? It will get over at machine 1 by 12 hours. And after that, we are not able to move this at the 12th hour. Because the previous job will get over by 15 hours in this machine. So in the machine la 15 hours fifth job process ஆயிட்டு இருக்கும். அது முடிச்சதுக்கு அப்புறம் தான் this machine will be free. After that only we can move this job to the second machine M2. Is it clear? So as it is, this value are not supposed to take. This value and this value have to compare, and whichever value is maximum we have to take here. So 15 is the maximum. Now 15 plus the processing time for job 3 in machine 2. So in job 3 in machine 2 the time duration is 6. Am I right? So plus 6 which is equal to 21. So compare these two. 21 is maximum, so 21 is the starting value. 21 plus the processing time for job 2 in machine 2. Job 2 in machine 2 is 10. So 21 plus 10 is 31. 27, 31. So 31 is the maximum. 31 plus for job 4 in machine 2 is 5. So it is 36. So this is the last time duration for processing all the jobs in both the machines. So the total elapsed time what we have to write now, that is 31 hours. I'm sorry, 36 hours. Okay, 36 hours. Now we have to find out what is the ideal time for machine 1 and machine 2. See, the machine 1 starts at 0 hour and 3 hours it will get over. Then 3 hours it starts, 7 hour it will get over. Then 7th hour it starts, 12th hour it get over. 12 it is, starts and 20th hour it get over. 20, 27. So 0 la start பண்ணி 3 la முடிஞ்சிருக்கு. 3 la start பண்ணி 7, 7 la start பண்ணி 12, 12 la start பண்ணி 20, 20 la start பண்ணி 27. So continuous it is working from 0 to 27. But in the project full முடியிறதுக்கு நமக்கு என்ன டைம் ஆச்சுன்னு பார்த்தோம், 36 hours. Okay, so complete பண்ணி டோட்டலா முடிச்சு வெளியில வரும்போது 36 hours ஆகுது. ஆனா machine 1 27 hoursலயே அதோட வேலையை முடிச்சிருது. Am I right? So 27 hoursல இருந்து 36 hours வரையும் அந்த machine வந்து workே பண்ணல. So it is ideal. So is it clear what I'm saying? இங்க வந்து continuous work பண்ணது எந்த பிரேக்கும் இல்ல. ஆனா 27லயே இது பிரேக் எடுத்துட்டு ப்ராஜெக்ட் முடிய நமக்கு 36 hours ஆகுது. So அதுக்கு ரெண்டுக்கும் நடுவுல உள்ள டிஃபரன்ஸ் பாத்தீங்கன்னா that is the ideal time for machine 1. So for machine 1 the ideal time is 36 minus 27. So 36 minus 27 that is 9 hours. 9 hours இந்த machine வந்து ஐடியலா இருக்கு, work பண்ணாம இருக்கு. Is it clear? Come to the second machine. second machine ideal time பார்த்தீங்கன்னா first it is starting at the third hour. So first 3 hours அது வேலையே பார்க்கல, third hourல இருந்து தான் ஸ்டார்ட் பண்ணியிருக்கு. So first 3 hours அந்த மெஷின் வேலை பார்க்கல, ரைட். 3 hoursல ஸ்டார்ட் பண்ணி 7 hoursல முடியுது. தென் 7 hoursல ஸ்டார்ட் பண்ணி 15ல ஸ்டார்ட் பண்ணி 21ல ஸ்டார்ட் பண்ணி 3 hours 31ல ஸ்டார்ட் பண்ணி 36 hours. 36 தான் நமக்கு முடிகிற ஜாப் முடிகிறதுக்கான டோட்டல் elapsed டைம். ஸோ 36 hoursல அந்த ஜாப் கம்ப்ளீட் ஆயிடுது. ஸோ ஃபர்ஸ்ட் 3 hours அந்த மெஷின் வந்து ஒர்க்கே பண்ணலை. So what is the ideal time for this machine? 3 hours. Is it clear? So 3 hours, this machine is not working. So these are the answers for this problem. The total elapsed time means the total project will get over by 36 hours. Ideal time for machine 1 is 9 hours. Ideal time for machine 2 is 3 hours. Is it clear? This is next problem. Quickly we can do because we saw one problem. Okay, so we are going to find the sequence to minimize the total elapsed time, and this is the order given, and we are going to find the total elapsed time. Even though they are not asking you to find the ideal time for machine 1 and machine 2 in this problem, you have to find it. I repeat, only they are asking you to find the total elapsed time, but you have to find the total elapsed time and ideal time for machine 1 and ideal time for machine 2. So totally 4 answers you have to find. First you have to find the sequence. Next you have to find the total elapsed time, then ideal time for machine 1 and ideal time for machine 2. Totally here we have 9 jobs processing through 2 machines. Okay, so we are going to move on to the solution. How we have to start? We have to locate the least value. What is the least value we have out of all the values? 2 is the least. Am I right? So it belongs to machine A. It belongs to 2 is the minimum. It belongs to machine 1 and job A. So where we have to start with? It belongs to machine 1. So we have to start from the left side. So 2 will come here. I'm sorry, not 2, I'm sorry. Job A, no. So A will come in this side. Okay, I repeat. 2 is the minimum out of all given values. 2 belongs to M1. So we have to start from left side. And this 2 belongs to the job A. So A, we have to start and we have to strike this job. Since we are not able to repeat it again. For that reason only we are striking it. Okay. Next minimum what we have is 3. We have that in 2 places, here and here. Okay, so 3 means we have to, since it belongs to M2 means we have to start from this side. In 2 places we have, so compare the other value and you have to take that as the first value. We are not supposed to take as it is 3, and the other value what we have is 6. 3, the other value what we have is 7. 6 is the minimum. So on comparison we are going to take this 3 as the first one. Okay, I repeat, since we have 2 values, I am not able to take as it is. I have to compare that with the other value. 6 is 7. 6 is the minimum. So the first job what I am going to take in the right side is E. So E, and the next job what I am going to start with this G. So E and G I have taken for the value 3. Now come to the next value 4. I have that into 2 places. Not 2, 3 places. This is not a problem because it belongs to M2. So we have to start that in this side. So D will automatically come in this side. This one is over. And these 2 belongs to M1 means compare the other value. Whichever value is minimum, we have to take that as the first value. So which is minimum? C. Because 7 is minimum. So C will come first and 11 is the next minimum. I will come second. Is it clear? So 4 is over. Now come to the next value 5. 5 also we have in 2 places. Both the values are same. So any one we can take as the first one and the next one. Okay. Either I can take B, H or HB. That is not a problem. I am going to take B first and H next. So B and H. The balance what I have is F. So this is the sequence, optimum sequence what we are getting. Optimal sequence or optimum sequence what we are getting. Okay, now we have to find the total elapsed time and ideal time for machine 1 and machine 2. This is the job sequence what we have, and we are going to fill the data here. the first job will start from the 0 hour. Am I right? And for job A, the time duration in machine 1 is 2. So 0 plus 2, 0 plus 2, which is 2. This 2 will come here. For C, the time duration is 4. So 2 plus 4, which is equal to 6. Am I right? Next, C will come here. For I, the duration is 4. So 6 plus 4, 10. 10. For B, the duration is 5. So 10 plus 5, 15. 15. For H, the duration is 5. So 15 plus 5, which is 20. Then 20 will come here. For F, the duration is 8. So 20 plus 8, which is 28. So 28. D is 9. So 28 plus 9, 37. 37. And for G, the duration is 7. So 37 plus 7, which is 44. And 44. For E, it is 6. So 44 plus 6, it is 50. So 50. Okay. So move on to the next machine. From 2 only it has to start. 2. Come to the time for 6. The value is 6. So 2 plus 6. What it is? 8. Before going into the step, we have to compare these two and we have to take the maximum. Maximum of 8, 6. 8 is the maximum. So 8 plus, for C, 7. So 8 plus 7, 15. And 10, 15. 15 is the maximum. 15 plus, for I, it is 11. So it is 26. Now 26, because 26 and 15, 26 is the minimum. So 26 we have to take. 26 plus, for B, 8. 26 plus 8, which is equal to 34. 34, 20. 34 is the maximum. Then 34 plus, for H, it is 8. So it is 42. Then 42, 28, 42. Then 42 plus 9, 51. 51, 37, 51. 51 plus 4, 55. 55, 44, 55. 55 plus, for G, 3. 58. 58, 50, 58. Then 58 plus E, 3. 61. So now we are going to write the answers. This is the total elapsed time, 61 hours. And ideal time for machine 1 is, it is continuously working from 0 to 50. Up to 61 it is ideal. So 61 minus 50, 11 hours it is not working. So 11 hours it is not working. For ideal machine time for machine 2 is continuously it is working. 8 then 8 starts 15, 15 starts 26. Continuously it is working, but the first 2 hours it is not working. So ideal time for machine 2 is 2 hours. Is it clear? The next type what we are having is, we are going to process n jobs through 3 machines. Already we have gone through n jobs to 2 machines. This is 3 machine problem. Okay. So we have machines M1, M2, M3 and they will give the order M1, then M2, M3. This is the order they will give. We are not able to do it using Johnson's algorithm directly, because in Johnson's method, we are able to process only 2 machines. So first we have to convert the 3 machine problem to 2 machine problem. So we are going to convert this and then we have to use Johnson's method. For conversion, we have this equation, because we have 3 machines in this order, M1, M2, M3. We are going to combine these two together as machine H, and we are going to combine these two together as K. H and K are the names which we are going to give. So adding these two machines, we are giving the name as H, and adding these two machines, we are going to give the name as K. Is it clear? Just like that, we are not able to add it. So add pananu abdina, we have a particular condition. What is the condition? From machines 1, 2, 3, they will give the data, no value. Out of that, we have to, for machine 1, we have to find the minimum for machine 1. And for machine 3 also, we have to find the minimum for machine 3. In between machine 2, we have to find the maximum for machine 2. So for machine 1 and machine 2, out of the given data, we have to find the minimum of it. And for machine 2, we have to take the maximum of it. And we have to compare these two. Minimum of M1 is greater than or equal to maximum of M2, or minimum of M3 is greater than or equal to maximum of M2. Okay, so minimum of M1 greater than or equal to maximum of M2, or minimum of M3 greater than or equal to maximum of M2. If any one condition is getting satisfied, means we can convert the 3 machine problem to 2 machine problem. So if it is not getting satisfied, means we are not able to do it. But if it gets satisfied, means we can convert the 2 machine to 3 machine. Is it clear? So we are going to do one example. Find the sequence that minimize the total elapsed time required to complete the following task on the machines in the order 1, 2, 3. Find also the minimum total elapsed time and the ideal time for the machines. And this is the data given M1, M2, M3, and we have 7 tasks, that is 7 job has to be processed in these machines. What is the condition I said? We have to find the minimum of M1, minimum of M3, and the maximum of M2. So these values we have to find and we have to compare. What is minimum of M1? 3. Minimum of M3, 5. Maximum of M2, 5. So minimum of M1 is 3. Minimum of maximum of M2 is 5, and minimum of M3 is 5. What is the condition we have to check? Either minimum of M1 is greater than or equal to maximum of M2, or minimum of M3 is greater than or equal to maximum of M2. Minimum of this 3 is not greater than or equal to 5. So the first condition is not getting satisfied. But this 5 is equal to 5. Either greater than or equal to we can check. So equal to, the second condition is getting satisfied. Any one condition has to be, we have to check. If one condition is getting satisfied, means we can convert the 3 machine problem to 2 machine. How to convert? Adding these two, we have to give the first name as H. Adding the other two, it is K. Am I right? So this is H, and adding these two, it is K. Adding these two means we have to give the labels H and K. No, so I have taken the other table with H and K. The first one is 3 plus 4, 7. Then 8 plus 3, 11. 7 plus 2, 9. 4 plus 5, 9. Then 9 plus 1, 10. And here 8 plus 4, 12. And 7 plus 3, 10. And taking these two. So 4 plus 6, 10. Then 3 plus 7, 10. 2 plus 5, 7. 5 plus 11, 16. 1 plus 5, 6. 4 plus 6, 10. Then 3 plus 12, 15. So now we have converted the 3 machine to 2 machine. Now we have to use Johnson's algorithm, which we know already. How to find it? We have to locate the minimum value out of the given values. Which is the minimum value we have? 6 is the minimum, right? So 6 is the minimum, means it belongs to the second machine. So we have to start E from the left side. So E. Next we can strike this E. What is the next minimum we have? 7. 7 in machine 1 and machine 2. 7 belongs to, this 7 belongs to machine 1. So A will come here. This 7 belongs to machine 2. So C will come here. So these two we have striked. What is the next minimum value we have? 9 is the minimum. Okay, so 9 belongs to D in machine 1. So D will come here. This one we can strike. What is the next minimum? We have 10 in 3 places. 1, 2, 3. This one belongs to machine 1. So we can take that here, G. This 10 in 2 places, no. Comparing these two values, we have to take the order. 11 is the minimum. So B first, then F second. Is it clear? Now come to the table. We are going to find the answers, that is total elapsed time, ideal time for machine 1, ideal time for machine 2 and ideal time for machine 3. If the ideal times are not asked, you have to find it. Okay, so all these 4 answers only you have to give. After getting the optimal sequence, this sequence, we have to find the total elapsed time, that is the last time, then ideal time for machine 1, machine 2 and machine 3. So starting from the first one, we have to start the first job at the 0 hour. In machine 1, A will take 3 hours. So 0 plus 3, it is 3. So the next one starts at 3. Next one is D. For D we have 4 hours. So 3 plus 4, which is 7. So 7 comes here. For G we have 7 hours. So 7 plus 7, which is 14. Then 14 for F. It is 8. So 14 plus 8, which is 22. For B, it is 8. So 30. 30 will come here. For C, it is 7. 30 plus 7, 37. For E, it is 9. So 37 plus 9, it is 46. Is it clear? So we have completed this one. Moving on to the next machine. We have to start the next machine at 3 hours. 3. Come to A. The time duration is 4. So 3 plus 4, 7. Both the values are same. So we can start from 7. For D, the second value is 5. 7 plus 5, it is 12. 7 plus 5, it is 12. So 12. Now we have to compare these two values. We have to take the maximum. 14 is the maximum. So next one will start by 14 hours. So 14 plus, for G, it is 3. So 14 plus 3, it is 17. Compare these two values. This is maximum. So 22 plus for F. So it is 26. Now compare these two. 30 is the maximum. 30 plus for B, 3. 33, 37, 37 is the maximum. 37 plus for C, 2. So it is 39. 39, 46. 46 is the maximum. Now 46 plus for E, 1. 50. Is it clear? Moving on to the third one. Third one is starts by 7 hours. For A, 6. So 7 plus 6, 13. 13, 12. 13 is the maximum. 13 plus 11. 24. 24, 17. 24 is the maximum. 24 plus for G, 12. 36, 36, 26. 36 is the maximum. 36 plus for F, 6. 42. So 42 is the maximum. 33, 42. 42 is the maximum. 42. 42 plus for P, 7. 49. 49, 39. 49 is the maximum. 49 plus for C, 5. 54, 50, 54 is the maximum. 54 plus for E 5. So it is 59. This is the total elapsed time. So 59 hours. For finding the ideal time for machine 1, it works continuously from 0 to 46, but the project will get over by 59 hours. So the ideal time for machine 1 is 59 minus 46. So 13 hours. This machine is ideal. For machine 2, it starts only at the third hour. So 3 hours it is not working. 7 continuously working. 12, but 14 only it starts the next job. So in between 2 hours it's not working. So that 2 will come here. And 17, 22. So 17 mudichittu 22 la it is starting back, right? So in between we have 5 hours. 26, 30. So 4 hours. And 33, 37. 4 hours. Plus 39, 46. So we have 7 hours. Plus 50 la it get over, but total project will get over by 9 hours. So 9. I repeat, 3 hours only it is starting. So 3 and 7, 12, but it starts by 14, 2, 17, 22. So 5 hours. 26, 30, 4 hours. 33, 37, 4 hours. 39, 46, 7 hours. 50, 59, 9 hours. So on the whole, the total what we are getting is 1 minute. There is a mistake in the last value here. I have taken 46 plus 1 as 50. It is not 50, it is 47. Okay, so 46 plus 1, it is 47. 54, 47, 54 is the maximum. So no change in this value. Only in the addition I have taken wrongly. So 47 it get over. So 59 minus 47. The difference what we have is 12, not 9. So on the whole, the final total what we are getting is 37 hours. 37 is the ideal time for machine 2. Come to the third machine. 7 as first 7 hours it is not working. Then 13 continuously working. 24 continuously working. 36 continuously working. 42 49 54 finally 59. So the first 7 hours only it is not working. So 7 hours is the ideal time for machine 3. So maximum completion for the project is 59 hours. That is the total elapsed time. And ideal time for machine 1, 2, 3 are 13, 37 and 7 hours. Is it clear? Thank you.